Welcome to today's roller coaster activity. I'm doing a video walkthrough for what you guys are going to be doing today. So each of you will be assigned one of these roller coaster tracks, a meter stick, this timekeeping equipment, and this white plastic marble. And at the end of this roller coaster lab, you will be able to calculate the kinetic energy, the potential energy at specific points on this track. You will also be able to observe the transfer of energy as it moves from one form to another on the track. On your Chromebooks, you guys will also have this data table that you will use to collect data at these markings on the track. Data points that you will collect first are heights on the track at these increments, and then the time it takes the ball to roll through past that increment on the track. Once you have these two rows complete, you'll then be able to go through and calculate the rest of the energy along the track. So, how do we do that? Well, one thing that's important to remember is that kinetic and potential energy are a measure of work. Work is measured in joules, and to calculate joules, we need kilograms for our mass, and we need meters for our distance, because we're going to measure speed in meters per second. And what's significant here is that, well, this is a really small marble, and this is a really light marble, so we're going to have to do some conversions in order to get the distance to meters and the weight in kilograms. The distance in meters, we'll get to that in a minute. So in order to calculate the mass of the marble, we place it on this scale that I have torn. If you remember from previous years in science, tearing the weight means setting the scale at 0 so you get an accurate reading. And we see that this marble weighs 1 gram. So what that means you're going to have to do is you're going to have to convert the 1 gram into kilograms. So we're starting here with our base unit, and you'll have the table here also, and you just have to convert 1 gram into kilograms. Now for the distance portion, we have to calculate speed in meters per second, and we're going to have to measure this marble. So I have this micrometer, and right now it's set to 0 millimeters. So what I'm going to do is open up the micrometer, and we can see that this marble measures 12 millimeters. Which we then have to convert from millimeters over to meters, the base unit. So you guys will do that. Width of the marble in meters, weight of the marble in kilograms. So why is it important that we have to have the distance of the marble in millimeters? It's because of the way the timekeeping equipment works. So for example, if I were to try to measure the speed of the marble at the 15 centimeter mark, I would have to connect the sensor on the track, and this is how you would do so. So you have this tightening handle that you're going to use to clamp it to the track, and I want you to notice that there is a little opening on this sensor. So what happens is, as the ball runs through, the sensor starts recording time at the front of the marble, and it stops recording time once the marble passes through. And that gives you the amount of seconds that it takes to have the marble pass through. Why we had to convert this distance into meters is because now, by converting this to meters, we can divide meters by seconds to get our meters per second. So we'll get our actual speed. How you will operate this is you will plug in the machine, you will turn it on, you'll make sure it's set to interval and that your timekeeping sensor is wired to point A. And what happens is, as the object goes through, you will notice time starts and end. So it starts recording time as my finger goes through and stops recording time once my finger is passed. If I were to measure my finger in millimeters and convert it to meters, I could then get the actual meters per second speed that my finger took to go through this portion of the track. So in this case, I'm going to roll the ball down, and it took 0.0116 seconds for the white marble to move through. So this time here, there's no conversion needed. You will just insert it at your table. The other important factor is our measurement. So on height of the track, to measure potential energy, each one of you will be assigned a meter stick that you will find at your station. So in order, let's say we wanted to calculate the height of the track at the 15 mark here. So I'm going to loosen the sensor, set it down, and what I will do is make sure I have it set at 0, and make sure you're not measuring over the sink trying to hold it in the air. If you have to move the track around to get your stick on the level surface, then you're free to move it so that you can get the accurate reading. Just do not try to eyeball a measurement by holding the stick in the air. So at the 15 centimeter mark on the track, let's calculate the height in centimeters. So here you could say we have, I'm trying to get it as close as I can, let's call that 32. From where I am, I can see that's 33. So let's call that 33 centimeters. So what we have to do then, for the height portion on our table, is we would take 33 centimeters and of course convert that over into meters. So once you guys record the height of the track at each one of these increments and the time that it takes to go through all these increments, we will meet back at the front of the class and we will discuss how to calculate the rest of the energy to complete the table.